Hello and welcome to another short video on solving a LeetCode problem with APL. In this video we're going to be tackling problem 1693, daily leads and partners. Alright, so this looks like another SQL type problem. So we're going to have a table containing daily sales, and we have 4 columns: the date, ID, the make name, which should be the name of the make of the sale probably, the lead ID and the partner ID. Now this table does not have a primary key. This table contains the date and the name of the product sold and the IDs of the lead and partner it was sold to. Fine. Now the name consists of only lowercase English letters, but I don't think we care about that restriction. Now we want to build an SQL query, or in our case we're going to use some APL to query the data and find for each data ID and name the number of distinct lead IDs and distinct partner IDs. We return the result table in any order, and the resulting format should be this: the data ID, the make name, and for each combination of both we want the lead ID and the partner ID. No, sorry, this was the input, my bad. This was the input and the output looks terrible. Let's see. Okay. Yeah. For each unique combination of date and make, we just count the uniques. Fine. Yeah, we can do this. Now, typing this in will be a pain. So what do I want to do? I guess I can just type a subset of this, but it feels like cheating. Alright, let's do the following. Let's go around it. So the dates are going to be these. Alright, so it's 3 times, no wait, this is going to do character by character, right? Yeah, exactly. So yeah, alright, so it's going to be 3 times that, and then it's going to be 2 times the 7th of December, and then it's going to be again 2 times, now it's the 8th, and then it's going to be 3 times the 7th. So these are the dates. Now for the makes we want 5 times Toyota and 5 times Honda. So these are the makes, and now the leads: 011, 001, 2012, and the partners are going to be 102, 21, 21121. Alright, so we have the dates, the makes, the leads, and the partners. Now let me zoom in or maximize the window. So this is our inverted table. Well, it's just this is actually the transposed matrix. The dates, the makes, the leads, and the partners make up our inverted table if we were to use inverted tables. So yeah, let's try to use the inverted table format. So what we want to do is key. We want to use key because we want to group by the date and the make. Alright, so in order to build these combinations and then use key on them, what we want to do is we want to take the dates and combine them with the makes. This is not, we don't really want to concatenate them like this, so over. Alright, so we want to put them together like this. And now we're going to use this as the unique keys. to key. Now this is the processing we're going to do, which is going to be counting the uniques. Now the data that we feed is going to be the unique leads and the unique partners. So it's going to be the leads and the partners. Now, there must be something, because we are using an inverted table and there's a lot of nice techniques that you can use on them. I just don't know them, but probably I should read about this. There should be something better than just doing the catenate each and the catenate over and close each here. So I'm probably missing something. But let's go with this for now. So let's see. This puts the leads and the partners together, right? So now what we're doing is we're grouping these leads and partners, or these IDs, by the date and the make. And over here what we get is a set of, so for each date and make we get a set of things. So for the first combination of date and make, we get this lead ID and partner ID for a sale, this lead and partner ID for another sale, and this for another sale. So these boxes here represent a date and a make, and the vector over here represents each individual sale related to that date and make. So now what we want to do is we want to count the uniques. So I just wanted to see the format of that. So if we mix, we get a matrix with leads on the first column, and partners on the second column. So we just need to count the uniques on each of the columns. So we can do that. Well, a silly way would be to take the tally of the union of each of the columns. So first we would need to transpose. And obviously I did something wrong. Wait, am I being silly here? Probably. Right, I need to transpose. I don't want to enclose. So I transpose, of course, and then I split, and then I do the tally of the union on each. And then we need to put this together with the information on the make and the date. Alright, so let's put this together like that. Yep, so is this correct? I think so. Let's check. So the 8th of December Toyota should be 23. Then the 7th of December for Toyota should be 12. 8th of December Honda 22, and then 32. Yeah, so the results are correct. Now I do feel like this is a bit clunky. So just to show you, we are building these nested vectors and then we are applying unique and tally to each. So these two vectors, this has 2 unique elements and this one has 3. These two vectors, this has a single unique element and this one has 2. So this feels a bit suboptimal. But this was the first thing that came to mind, so this is what I'm posting. And as a challenge to you, well, you have to figure out something better. Maybe it doesn't make much sense to use this as an inverted table, or maybe the issue comes from the way I'm using this, because I'm essentially just going back to the format that I'm most used to. So if you have any alternative suggestions, feel free to comment them below, and or add your own solution to the GitHub repository, and I'll see you soon. Bye.